Hello, today we will see the Java pattern matching with instance of, with theme Paris monuments. Pattern matching in Java lets you check whether an object fits a specific structure, like a class, and if it does, automatically extract information from it. It improves clarity, safety, and reduces boilerplate code, especially when used with the instance of operator. Note: introduced officially in JEP 394, pattern matching for instance of is available from Java 16 and onwards. What is pattern matching? Traditionally, when you wanted to work with a specific subtype of an object, you needed to 1. Test the type with instance of, 2. Cast it to the target class, 3. Use it in specific field or method. Let's illustrate this with a theme of Paris monument. We'll model some famous landmarks with a monument interface. So the traditional instance of usage. So here the snippets explicitly the old-fashioned way of doing some type testing. So here you have an interface monument with a static method get8description taking a monument as parameter, and you have some branching statement if, else if, and else, which test for the first one if m instance of Eiffel Tower, then else if m instance of Arc de Triomphe, and the else throw an illegal argument exception. And you have two classes, Eiffel Tower, which implements monument, and Arc de Triomphe, which implements also a monument. So this code works but requires explicit casting, which is repetitive and error prone. You see, here you have to explicit cast the parameter in the condition, and with Eiffel Tower, and same for Arc de Triomphe. And this is a bit overkill. Next, enter pattern matching. Pattern matching lets you streamline the code and safely access subclass data without casting. If we take the previous example, we can do it with only this code snippet. We have a condition: if m instance of Eiffel Tower E, then we directly return Eiffel Tower is E.8 plus metaphor, and same for Arc de Triomphe. And if you see the previous example, here we have one statement like this, and we exploit directly the parameter. And here you have to declare the Eiffel Tower E, to cast it from the monument M, and then to return the expression. So from 2 lines, we get to 1 line. It is simpler and cleaner. Notice how we test the type. Declare a variable E or A of the right type Arc de Triomphe and Eiffel Tower. Access the data without casting. We access the data without putting some type between parentheses just before. Shorter, cleaner, and safer. Next, breakdown of a pattern. Consider this pattern: M instance of Eiffel Tower E. It consists of a predicate, instance of Eiffel Tower. This is the predicate. Check the type, target M. This is the target which will be tested, the object being tested. Pattern variable E, available if the test pass. So this will be used in the following statements after the condition validation. Next, scope of pattern variable. Pattern variable like E and A only exist when the instance of check is true. For example, in this code snippet, we have a method, public static boolean install monument taking as parameter a monument M, and if M instance of Eiffel Tower E, if M is not a Eiffel Tower, then we return false. Else, we return E.8 greater than 300. And you see, we have here the variable of the instance of, and it is exploit out of the if, but E is safely in scope here because it is the following. There is still in the same scope. Then can also be used directly in complex condition. For example, if m instance of Eiffel Tower E and E.8 greater than 300, you see here we re-exploit in a new condition the parameter defined in the instance of. And so then you print something, a very tall Eiffel Tower. But be careful, this is not allowed. If an instance of Eiffel Tower E or E.8 greater than 300, this won't work. You will have a compiler, it might not be initialized if instance of is false. Because this is not always true, so we can't be sure E will be defined, so it won't compile. Next, to conclude, pattern matching with instance of reduce casting, makes your code cleaner and more maintainable, prevents accidental bugs due to mismatched types, and is especially helpful when working with complex object models or iconic monuments. Thank you very much, and maybe see you in another video. Bye.